Matrices Algebra 2 Lesson 3-6, Solving Systems Using Matrices. A matrix is a rectangular array of numbers written within brackets. A matrix element is each number in a matrix, and a row operation can be something as simple as adding rows, subtracting rows, switching rows, or multiplying rows. Matrices are a helpful way to organize numerical data. A matrix is represented with a capital letter and classified by its dimensions. The number of horizontal rows and the number of vertical columns determine the dimensions of a matrix. And a matrix is always written in rows by columns, must be. So matrix A here is a 2 by 3 matrix because it has 2 rows and 3 columns. Okay, this is row 1, this is row 2, those are rows. And columns go up and down. 1 column, 2 columns, 3 columns. Remember, columns hold up buildings. So this is a 2 by 3 matrix, row by column. Always read row by column. Very important. You can identify each element of the matrix by its position within the matrix. Use a lowercase letter with subscripts. The subscript represents the element's row number and column number. So, for example, identify A21 in matrix A. A21 is, okay, A21 means row 2, column 1 in matrix A. So I'm going to go here, and I'm going to go to row 2. Okay, here's row 2. And I'm going to go column 1, where do both the green and the yellow intersect? 10.4. Therefore, row 2, column 1 is 10.4. That's the element of row 2, column 1. Now, we're going to identify certain elements in this matrix K. First, we're going to identify K12, which is row 1, column 2. Row 1 is this row, column 2 is this column. So row 1, column 2, that element is -1. Row 3, column 2, row 3, column 2 is -4. I'm going to erase some of this stuff so you can actually see. If we go to K23, that happens to be row 2, column 3, and that happens to be the number 4. And last but not least, K34 is row 3, column 4, which is -5. So it's not hard to read elements off of a matrix. You just have to remember it's always row by column. Now, you can represent a system of equations efficiently within a matrix. Each matrix row represents an equation. The last matrix column shows the constraint to the right of the equal signs. Each of the other columns shows the coefficients of one of the variables. You don't put the variables in, you just put the numbers in. So how do we represent a system of equations within a matrix? All right, let's take a look at this first one here. If I was going to represent -4x minus 2y equals 7 as a matrix, and then 3x plus y minus equals -5, this matrix would be a 2-row, 3-column matrix because it's got 2 variables and an answer column. Okay. So I'm just going to plug in -4, -2, 7, 3, 1, and -5. Answer column always has to go to the right of a vertical line, and the matrix is in brackets. So you just put in the coefficients, the equal sign goes after the vertical line, whatever numbers those happen to be, and that's the matrix. If you look at this second one here, this would be 4, -1, 2, 1. Notice there is no x value, so I have to put in a 0 for x, because there's no, in this second equation we have 1 y, we have 5z, and we have 20, but we don't have an x, so you have to put in a 0 so that the matrix gets filled with something that we can't leave it blank. Okay. This third equation, it's not written in x, y form, so it would be 2x plus y plus 0z equals 7. So we have to make sure that that's written in that form before we can put it in the matrix. So it's 2, 1, 0, 7. And again, closing brackets. And there's a matrix. you should be able to do the opposite. If you're given a matrix, can you write the equations for the new systems that make up this matrix? So if we just go following this row, we would have negative 2x plus 4y plus 9z equals 0. If we were to follow the middle row, that would be negative x or negative 1x plus 3y plus 0z, or you could just leave it out, equals 7. You could have 0z or just nothing. And then, of course, the last row, 5x plus 5 plus 9z equals 8. So this would be the system of equations for that particular matrix. So writing a matrix, understanding a matrix, not so hard so far. Take a look at a few other things. You can use a matrix that represents a system of equations to solve the system. In this way, you do not have to write all the variables. To solve the system, use row operations to get a matrix in the following form. You either want to get it as 1, 0, and a variable, and 0, 1, and a variable. In other words, it's going to be 1, 0, and a number, 0, 1, and a number, or 1, 0, 0 number, 0, 1, 0 number, 0, 0, 1. Notice there's a diagonal of 1s, and everything else is 0 except for in the solution line. Okay. All right, so to do that, you can use row operations. Okay. You can switch any two rows. If I switch row 1 and 2 of the matrix 4, 5, 3, 3, 2, 6, it would become 3, 2, 6, and then it would be 4, 5, 3. We would just interchange the rows. It's perfectly acceptable. You can multiply a row by a constant. If I multiply row 2 by 3, you would have 4, 5, 3 as the top row will stay the same. It would be 3 times 2. Wait a second. Fix that. 3 times 3, because we're multiplying row 2 by 3. And we're multiplying by 3, that's why I have a 3 on the outside. So this would be 3 times 3, 3 times 2, 3 times 6, which would give us the matrix 4, 5, 3. And on the bottom, we would have 9, 6, 18. 9, 6, 18. 9, 6, 18. You can add one row to another row. If I added row 2 to row 1, okay, if I add row 2 to row 1, I get 4 plus 3, 5 plus 2, and then 3 plus 6. And the bottom row stays the same, 3 through 6. So the top row becomes 7, 7, 9, and the bottom row stays as 3 through 6. You can use any of these combinations to solve a matrix. Okay? Solving a matrix means you want to get it into the form of either this 1, 0a and 0, 1b, or 1, 0, 0, 0, 1, 0, 0, 0, 1. That's the depends on if it's 3 variables and 3 unknowns or 2 variables and 2 unknowns. We're never going to go more than 3 and 2 by hand. So we're going to solve a matrix. Okay, what is the solution to this system? So the first thing we have to do, we have to write the matrix. So let's write the matrix. 1, 2, 16, 3, 1, 8. Our goal is to get it to look like this. And there's going to be a number here, and there's going to be a number here with zeros. So we want to get it as 1, 0, 0, 1. Notice we have the 1s in the right places. We need to just get some zeros. So somehow we've got to get rid of the 2 and the 3 and have them become zeros. Okay. So I can't multiply something by 0 because it's going to create all zeros. So what I'm going to do here is I'm going to keep my matrix, and I'm going to take row 2 and multiply by negative 2. It's the first thing I'm going to do. So I'm going to multiply negative 2 by row 2. Okay, so I'm going to have 1, 2, 16. If I multiply row 2 by negative 2, I'm going to have negative 6, negative 2, negative 16. So that's my new matrix now. Okay? And then I'm going to add row 1 and row 2 to give me a new row 1. Okay? So if I add them together, I'm going to stay with my first. Actually, I'm just going to get it to. It doesn't matter. I'm just going to add them together. I'm going to keep. So I'm going to add row 1 to row 2 and give me a new row 2. So I'm going to keep row 1 on the top, 1, 2, 16, and the bottom 1 and negative 6 is negative 5. Okay, 2 and negative 2 is 0. 16 and negative 16 is 0. So there's my new matrix after I added row 1 to row 2. Row 1 plus row 2 to give me a new row 2. I kind of do that so I know what the color is doing. That's my shorthand for saying, oh, what did I just do? Right? So now what I need to do is I look at this and go, I'm really close. I've got the one in the right place. I lost my other one, so you might go, well, you just messed this up. Now you've got all kinds of interesting things. Well, no, not necessarily. I'm going to interchange row 1 and 2. Right? Row 1 is going to interchange with row 2. So that's going to give me negative 5, 0. Oops, I don't need commas. Negative 5, 0, 0, 1, 2, 16. All I did was interchange the lists. Now I'm going to take row 1 and multiply it by negative 1/5, or divide it by negative 5, same thing. Okay, so row 1 multiplied by negative 1/5 to give me a new row 1. So that's going to be negative 1, 0, 0, and here I've got 1, 2, 16. Okay, so I have a negative 1. I need a positive 1. So, well, actually, no, I divided by negative 1 here, so that makes it a positive 1. I messed up that. So negative divided by negative, or negative times a negative is a positive. So I have 1, 0, 0, 1, 2, 16. So all I need to do is get this 2 to be a 0, or excuse me, to be a 1. So I'm going to take row 2, and I'm going to divide it by 2. So 1/2 row 2 to give me a new row 2. So row 1 is 1, 0, 0. Row 2 is 1. Okay. Now it's 1, 1, 16. So I'm getting closer. All I need to do now is have this become a 0. Okay. So I have 1, 0, 0, 1, 1, 16. Actually, I don't like that. Let's go back a step. I don't like that. Let's just go back to this step right here. What if they use pencils? Okay. I have a 1, 0, 0 and a 1, 2, 16. If I multiplied row 2 by a negative 1 and then added it, I get a new row 2. So let's do negative 2 times row 1, add that to negative 2 times row 2. Negative 2 times row 2, add that to row 1 to give me a new row 2. So now I still have 1, 0, 0. Here I'm going to have a negative 1, negative 2, negative 16. So there's my new matrix. I'm going to add them now, give me a new row 2, so I'm going to have a 1, 0, 0. If I add these two together, negative 1 and 1 is 0. 0 and negative 2 is still negative 2, and 0 and negative 16 is negative 16. So I have now 1, 0, 0, negative 2. Last thing I need to do is get that rid of that negative 2 and have it become a positive 1. To do that, I'm going to divide everything by negative 2 and multiply everything by negative 1/2. Negative 1/2 row 2 to give me a new row 2. So I'm going to have 1, 0, 0. Negative 1/2 times 0 is 0. Negative 1/2 times negative 2 is positive 1. And negative 1/2 times 16 is 8. And that's my final matrix. I now have it as exactly what I needed, a diagonal of 1s, and everything else is 0 on the left-hand side. And on the right-hand side is my solution. So my solution to this inequality, or equation, is 0, 8. Now, when I was in college, I had to do a ton of these. And the 3x3s were very, very, very complicated. It could take you a page and a half, 2 pages to do one of these. Essentially, you're doing the same thing you were doing with elimination and substitution, so you don't have variables. This can get very cumbersome, and you can make lots of mistakes, which means there's got to be an easier way. And there is. Your calculator can do something for you. I'm going to show you, walk you through it on the TI-84. I will do a separate video to doing it on the Inspire calculator. So if you have an 84, just follow along. If you don't have an 84, just pay attention. The Inspire is going to be similar, but there's quite a few keystrokes. So, and I want to be able to show those. So the first thing we're going to do is we're going to use a calculator to do this. First thing we're going to do is we're going to write the matrix. So here we have 3, 2, -1, 7, and then we have 2, 0, -1, 5, and the third row is 1, -4, 1, -4. So there's our matrix. The next thing we have to do is we have to put this into our calculator. So you're going to find your matrix key again. If you remember, that's your matrix key here is right underneath your math key. It's blue, so you have to hit the second x to the negative first key. Okay, second, and then you have this little key. Hit that, and it's going to bring up names, math, and edit. Right? You're going to edit. Okay, and it's okay. So you're going to hit edit. And underneath that, you have A, B, C, D, E, F, G. Some of them might have numbers in them, depending on who's plugged in your calculator and who hasn't. I have A as a 3 by 3. This is not a 3 by 3. This is a 3 by 4 matrix. 3 rows, 4 columns. 3 by 4 matrix. So I'm going to edit A, and instead of a 3 by 3, I'm going to put in 3 by 4. So I'm just going to type in 3 by 4. And then it's going to highlight. If there's already numbers in there, just type in the right numbers in the right places. So I'm going to put in 3, enter, 2, enter, -1, enter, 7, enter, and then 2, enter, 0, enter, -1, enter, 5, and last 1, enter, -4, enter, 1, enter, 4, enter. So now I have my matrix. I'm going to get out of that matrix. I'm going to hit second quit. Okay, second mode button gives you second quit. Now, there's interesting things with matrices. Matrices can do all kinds of things. So we need to do some math. And we're going to do math because what we find is a matrix that represents the solution of a system is what's called reduced row echelon form. And many calculators have a RREF function, which is the reduced row echelon form, RREF. And we're looking for RREF, reduced row echelon form, to solve your matrix. So the first thing I'm going to do is I'm going to go back to matrix, second, x1. Now I'm going to scroll over till it hits math, and I'm going to go look down until I can find RREF. Okay, that would be letter B. Letter A is REF, we need RREF. So hit letter B, hit enter, and it's going to say RREF, and it's going to give you a parenthesis. Now go to your matrix, so hit second matrix again. We need matrix A, so just hit A. Okay, so now in your calculator, you should have this on your screen. Okay, you're just going to hit enter, and it's going to come up as a matrix. You're going to hopefully get this: 1, 0, 0, 1, 0, 1, 0, 5, 0, 0, 1, 3. And of course, if this was not a decimal in which you could, it was a repeating decimal, you would just hit math, enter, enter to get this as a fraction. Okay? So my solutions then to this particular matrix is 1 half, -3. Much faster than doing your own row operations. Matrices using a calculator is much, much faster. Okay? Actually, the matrix chapter is chapter 12 in this particular textbook that we're working with. We will actually do that chapter next before we do chapter 4, because there are so many things you can do with the matrix that will help you in subsequent coming chapters.